Recall error has two definitions in science. It's a measurement where a mistake has been made, or the difference between a measurement and the actual value. There are three types of error. One is systematic, where equipment is calibrated incorrectly or is faulty. An example of this can be seen in this image, where the ruler is measuring a piece of wood. At first glance, it may seem like the ruler is fine, but take a closer look. The ruler has been cut so that if you're not aware, it will provide you with the wrong measurement. The other types of error are random error, where there seems to be a fluctuation in the measure due to variables that are seemingly uncontrollable, like the wind and background noise. Human error is another type of error that may occur, and some may suggest that the green ruler was being used incorrectly, so it also shows human error. But this type of error, when detected, must be corrected. It's not acceptable. Absolute error, the difference between your measurement and the actual value. Percent error, the absolute error represented as a percentage. And percent difference, the difference between two separate measurements. Uncertainty is doubt that a measurement is accurate. This is due to the quality of the equipment and the ability of the user. Uncertainty is not an error in measurement due to a mistake. It is not a systematic or human error. Using a centimeter ruler, it's obvious that the book is wider than 5 centimeters but less than 6 centimeters. Why can't we be more exact? Because the equipment scale does not provide us with the ability to make a more exact measurement. Its markings, also known as its graduations, are 1 centimeter apart. What we are certain of is the fact that the book is greater than 5 centimeters but less than 6, as represented by the red bar on the ruler. Although we cannot be certain what the exact width is, we know that the measurement is greater than 5 centimeters, which allows us to estimate the next place, possibly 5.3 centimeters. Because we are not certain, we must include an amount on either side of the 5.3 centimeters, which would include the actual width of the book, with near 100% certainty. Usually, it's 1/2 of the smallest graduation of the measuring device, which would be 1/2 centimeter. Therefore, our final measurement would be 5.3 centimeters plus or minus 0.5 centimeters. This means that the actual width of the book is anywhere from 4.8 centimeters to 5.8 centimeters, with near 100% certainty. Unfortunately, uncertainty is found in every single measurement that a scientist will make, with the only exception being counting. Calculating uncertainty is not an easy task. Often we will say that the uncertainty in a measurement is 1/2 the smallest graduation of the measuring device, but it also includes your confidence in making a measurement. A good example of this may be trying to measure an object like a tennis ball. I am not placing a ruler on top of the ball in this picture because we would not be able to do this with a real tennis ball due to its belly. The width of the ball is more challenging to measure due to the fuzzy felt, its circular shape, and its belly. If you measure the ball's diameter, you may wish to make your uncertainty greater than 1/2 the smallest graduation. Using different tools may provide you with different results. Remember, uncertainty is a product of the quality of the measuring device and the confidence of the user. The next example is of the same book using a millimeter ruler instead. It looks to me that the book is somewhere between 52 and 53 millimeters wide, or 5.2 to 5.3 centimeters wide. If we are certain of the 5 centimeters and the 2 millimeters, this allows us to estimate the last decimal place, which looks like 1/2 a millimeter. So my measure is 5.25 centimeters. The uncertainty will be 1/2 of the smallest graduation. My final measurement will be 5.25 plus or minus 0.05 centimeters. The uncertainty usually is to the last decimal place as the measurement that it is attached to. As you can see, the better quality of the measuring device, the better the measurement that we can make. Our last example is of the same book but with a decimeter scale ruler, which has 10 centimeter graduations. With this ruler, we can definitely say it's between 0 and 10 centimeters. Although there are no other graduations, I think it's safe to say that it looks somewhere between 4 to 6 centimeters wide. Although earlier we suggested that the uncertainty be 1/2 the smallest graduation, in this case I feel that plus or minus 5 centimeters seems too broad. In my mind, I think that 5 centimeters plus or minus 2 centimeters may be ideal. You may feel more confident in your measure and have a smaller uncertainty, but usually the uncertainty goes to the same decimal place as the measurement that is attached to, so I would not suggest something like 5 centimeters plus or minus 1.5 centimeters.